Okay, we can see your shared slide. Yeah, I'm sharing the DBMS slide. So there are maybe very few in the slide. Can't you still see the slide? Okay. So please answer questions. Uh, in the meantime, right. So I will explain the hierarchy of data. So as I explained earlier, so database has files. So those files contain records, and those records will be based on in each field. Let's say in this example, so there can be databases for personal files, department files, and payroll. And when we take each file, so those have uh, let's can be in some in company. There may be thousands of workers. So those workers information will be saved. Their employee number, name, their date of birth, and those are the records. And the fields. So let's say we are storing the first name. So then the field will be string or characters. And if you are storing the age, so the field should be date. And by going deeper, so each of those let's say date of birth, so then we will store some numbers. And if we take name, so it should be some character. So it will be stored in characters. And likewise, those characters will be again representing, as mentioned here, also the in a bitwise manner using ones and zeros, right? So this is the hierarchy of storing data in a database, and DBMS will allow us to restore, manage, and safely store this data and working with very efficient. Okay, so business intelligence. So this is some nice example where I don't exactly remember the year, but in Virginia, in United States, there were a system uh, that stored where some crimes are happened, and the relevant data code for a particular list of crimes, and that system has generates BI reports. So in that reports, they can easily pinpoint or recognize some patterns where a particular crime can happen. So that means there may be some set of related data need to gather. Then we can assume then it going to be a crime in that particular location. So the police department or law enforcement authorized says officers uh, will be able to avoid those crimes before that is going to happen, right? That means allocate manpower to that particular location. Investigations can do so. Likewise, there are some drawbacks also, but those systems can able to generate some prediction mind patterns uh, by using the previous data. Right. So, what are the components in databases? So, I have list few components: entities, attribute, data key, primary keys. Yeah, those are the some major components when we are describing a database. So, what are the entities? So, definition is, so an entity refers to a person, place, or thing, that means object, for which data is collected and stored and maintained, right? So as mentioned here, so examples are employees, products, and customers. So importance is uh, entities form the basic building blocks of a database and represent real-world objects or concepts. So the key points are, so data collection and maintenance are centered around the entities. So entities help structure and organize data effectively. So we'll go back to the attributes. So definition is, so attribute is a characteristic of a or property of an entity, right? So that means we take a employee entity. So attributes could be employee number, last name, and first name, hire date, and maybe the department number. So attributes provide details and information about the particular entity and they associated with. So attributes provide the way to describe and differentiate entities, and they will help storing specific information related to entities. So please ask questions if you don't understand these concepts. So I'll keep forward. So data keys. So data key refers to a field within a record uh, that is utilized to identify that record. Uh, so the purpose of data keys allow for unique identification or individual records within a dataset. So that means they serve as a reference points for accessing data. So without data key, actually we can't access a particular data. So data may be stored in various types, and those data is it's about a particular attribute of a selected entity, and we need to identify a particular key data that will need to get access to the relevant data of a selected record. So what is the primary key? So it is also a data key. So primary key is a field or set of fields. That means there can be one set of field or can be multiple fields, but they should be uniquely identify a particular record within a database. So as example, the employee number. can be a primary key for an employee entity. So primary keys plays a crucial role in maintaining data integrity and ensuring the uniqueness. So primary key prevents duplicates and redundant records, and they are essential for establishing relationship between data entities. So you will learn about more about those relationships in today's lecture. So the primary key will allow a particular data to access and uniquely identify that particular data point. So as a summary, so entities represent objects in database, and attributes define the characteristic of that particular object, and data keys will allow for record identification, and the primary keys ensure the record uniqueness. So please ask any questions. If you have, you can even raise your hand and ask. So I'm keep forward. So database approach. So database approach is a method used by most organizations for efficient data management, where various information systems share a common pool of interconnected data. And what is the importance is this approach promotes data consistency, accuracy, and accessibility across different functions and departments. And the multiple information systems benefit from a unified data source. So promotes streamlined data sharing and collaboration. So when it comes to the database management system, DBMS, so it is essential for implementing the database approach to data management. So the function is DBMS is a collection of programs that serves as a intermediary between the database and its users. So database provides tools for creating, managing, and interacting with databases, and it ensures the integrity, as I mentioned earlier, integrity, security, and efficient query. So the components. So data definition language, DDL. And used to define the structure and layout of database. So the next component of DBMS is data manipulation language, DML. So enables users to interact with and manipulate data. And other thing is we can say it is DQL, data query language. So that is supposed to query and retrieving specific information from database, and the importance of these are these components collectively enable efficient data management and retrieval. So when it comes to the benefit of this database approach, that is the centralized data reduce redundancy and ensure the consistent and accurate information, and improve data security. That means access control and permissions can be enforced through the DBMs, and efficient data sharing. It means different systems can access the same data pool, reducing the data and data conflicts and simplified data maintenance. So that means changes can be made at one place and benefiting all the system facilitate the decision making. So uh, so let's go to the steps of this database approach. Those are define database structure. You can use DDL. So DDL is data definition language to create the schema and tables and populate data. So by using DM, data manipulation language to insert relevant data into the database and interact with data. So users query and manipulate data using, as I mentioned, the DML and the DQL. DQL is data query language. So SQL is such data query language. So the key points are the clear database design is crucial for efficient implementation and users interact with data without needing to understand its underlying structure. So let's go to the structure database approach. That means database management system will be in the middle, database and the users. So users will interact with each database management system, and database management system will retrieve those relevant data from a database, and even he can pass or store data that will given by the users. And each systems, as mentioned here, the application programs can generate reports, as I mentioned in this business intelligence also. Those reports can identify by using those pattern reports can be identify any patterns, and even we can pinpoint some relevant or major change, can highlight some major points through the our database and about our data, right? So this is how actually we are defining a database and DBMS system, and how we need to work in a select in a particular application. So these are just some basic ideas. So we will learn about more those DDL, DQL, and DML. And before going into the those details, so if you have any questions, you can ask. So next time, starting with the how to model in and those relationships. Students. Okay, then move forward. So understanding data modeling. So by definition, the data modeling is it's a tool used to database designers to like to map or to depict the logical relationships between those various kind of data elements. So that means we are there are a set of tools and we need to to actually understand about the structure and the relationship between data, and then we can design our database. So there are some concepts, name normalization, and those, especially you are working with databases. So you should aware those concepts. So those concepts are we'll discuss under the data model. So data models provide a visual representation that may aid in design efficient databases and understanding data interactions. So that means those data models bridge the gap between the business requirements. That means the user needs and the technical implementation. So they enhance communication among the stakeholders, users and the database designers and like those who are working with the industry like software engineers and all. So that means if you need to create a particular application and you need to get the user requirements, and in that requirement there is a whole ER diagram and some sequential diagrams and all. Those will help to understand each components to the client side and the development side as well. So then what is a data model? So the definition is data model is a graphical representation illustrating entities and their relationship within a specific domain. That means the problem. So data models help in comprehending the structure and connection among different data components. So as I mentioned earlier, so in when we are dealing with data, so those data has entities, attributes, and all. So entities are represented as object in, and relations are depicted with lines. So that is the visual tool for designers to develop, designers, developers, and stakeholders. So I will quickly show you ER diagram. I think now you can see the ER diagram as I mentioned. So this customer, order, and product, those are the so-called entities. And this ID, name, status, and number, those are the selected attributes. And what this line means, so that means customer places orders, right? So this one and n means there can be the one customer can have many number of orders. So this is the relationship. So that means we need to take this ID and some unique identification of this order. So unique identification will be the order number. So there should be a table that which has a unique identification with ID and the order number. So those both those two fields will be the primary key for that particular order. So though you will be probably learn more about those in what you're doing with databases. So this is some simple idea, right? So even if you say this one, order and product, so that means order include products. So in that relation, includes relation, there should be the amount. So that means in particular order, there should be here some number of products that is represented in here. Go back to the lecture. So those are the visual tools or visual identification. So there are many number of tools also to design such diagrams, and you will probably you can actually search through in internet and find out, and probably will learn more about those database tools, database modeling tools in future lectures in databases. So the process of data modeling. So process will be first, you need to identify the problem. That means you need to grasp the business problem which is need to be solved. And then you need to data analysis. That means identifying the data and information required for solution. There can be many number of data which may redundant for your particular problem. And what you need to do is you need to highlight what are the necessary information, data that you need to that will need to solve the particular problem. Then you can start the model creation. That means developing a visual diagram showing entities and relationship as I show you earlier. So those are the steps you need to follow. So yeah. So data modeling aligns technology with business needs, and it ensures that the database design is relevant and effective. So in the enterprise level, the data model involves analyzing the data needs of an entire organization. So then now we are talking with the enterprise level, and it offers a like roadmap for constructing a compatible and integrated database and information systems. So so that means you need to so in such enterprise level modeling, there should be maintained a single format of a definition of the data for ensuring the consistency. And data exchange and integration among systems will be facilitated in such enterprise level. So in enterprise level, these factors need to be considered that are consistent. That means uniform data definition and single particular format need to maintain across the system. And integration. Integration is facilitate data exchange between the each number of systems. And the compatibility. So that means ensure the interportability or the interoperability among databases and applications. That means there can be many number of databases and many number of applications. So the model should be compatible for every application and database. It's not going to compatible, so it will going to fail in enterprise level. If you can do a small kind of activities, or small business or startups, but in enterprise level, when you are working with many number of projects, and also the compatibility need to be there, and there should be reduced redundancy. That means minimize the duplicates. So it means if the single record going to duplicate in every database, so in enterprise level there can be thousands, like millions of billions of data points. So if a particular data going to be duplicate, then there will be need for higher uh, memory and higher storage capacity. But even then, those are irrelevant to store because you already stored that particular data. So reduced redundancy need to be maintained, and it should be need for long-term strategy. That means if you in enterprise level, if you develop a particular model that will going to last for a few number of years. If it's going to last for only 1 month, then the model will not be suitable for enterprise level. Right. So as a recap, so data modeling is a visual approach to represent data relationship. And the purpose is to bridge between business requirement and technical implementation. So in enterprise level, the approach for organization and wide data consistency and compatibility. So data modeling is the fundamental step toward building effective databases and information systems. So let's go back to those detail, those in detail. So entity relationship. So as I previously showed you the ER diagrams. The part of the particular ER diagram. So an ER diagram, entity relationship, is a graphical representation that employs basic symbols to illustrate the organization and relationships within the data. So let's go back to the diagram. So as shown here, the relationship with these entities, customers and orders. So relationship is place. So that means customer places orders. So those can be captured by go through with the requirement. So here the requirements are customer places orders, and order includes product. Those two requirements are mentioned here. So ER diagram display data items in the form of tables. That means those uh, squares about entities, and depict the ways these entities are interconnected. So ER diagrams provide clear overview of data, structure, and relationships in a visual way. So it's kind of a visual tool. So what are the components? So those are, as we mentioned, the entities. So it represents the data items or concept and the relationship. So shows the connection between one or two entities. There can be more than the two entities of a relationship, and the other thing, attributes. So those are the properties of entities that so the ER diagram will represent all of these entities, relationships, and attributes, and we can show the primary keys and all. And so entities and relationships are visually connected using lines, and attributes provide the additional information about that particular entity. So importance in ER diagrams. So ensure accurate and well-structured relationship among data entities. And they align application programs is business operations and user requirement. And it will be a reference document. So ER diagram remain valuable resources after database deployment. And the one major thing is we can adapt into the changes. So that means when you are working with such kind of information systems, the user requirement will be varying time to time, and we need to adapt to that particular requirement. So in ER diagrams, aid in designing changes when database modification occur. So the benefits are, so it's assisting creating database schemas during the process, and in implementation phase, it will help to developers to understand the data interconnection, and after post deployment. So that means you already deployed the your projects, then the ER diagram serves as a documentation and reference for maintenance. Right. So as a recap, so ER diagrams visually represent data structure and relationships using basic symbols. So the purpose is bridge the gap between data concepts and technical implementations, and will maintain the consistency and adaptation. So ER diagrams ensure accurate relationships and facilitate changes. So ER diagrams is essential for designing, understanding, and maintaining databases. So, uh, so in ER diagram, so I have explained the relations between uh, two or more entities. So, with that idea, so the relational databases are developed. So, relational database model is a straightforward and a powerful method to organize data into the collection of two-dimensional tables. And you already work with in Access, and some of you have already used the SQL servers. And this model forms the foundation for modern database management systems and enables efficient data storage and retrieval. So tables are easy to understand and manage. So as mentioned here, the project table. So the project table has the project ID, description, and the department number. And the department table, it's also the same department number is there, and department name, and manage the SSA. So if we take a particular project, let's say 155, so it is about the payroll, and it is under department of 257. Then we need to if we need to get back to the what is the name of that department, so we can retrieve through by the other table, department table, by using the identification, that is the department number. And then we go to the department table. There we can find out that the department table is accounting, right? So as I mentioned, tables are easy to understand and manage, and they can be linked with linked and to can establish a relationship to link with other database. So those are the major points: simplicity and flexibility. So so I will go through some of those uh, queries that you can connect those relationships and uh, like in relational database models. So you can easily manage those data. So there are other database models also, but for understanding, for starting up, you can start with this database. So in let's say some cases, there are the relational databases will not going to do any improvement. So in some cases, that means relational databases not going to have more accuracy, and we need to deal with those data. Then it will be very hard to find a particular record, and so that's a so there are some other concepts also, and you can learn more about those in doing the databases and implementing the particular softwares. So the components of a relational model, as mentioned earlier, the entities and attributes. So those are the rows represent the entities, and the columns represent the attributes of those entities. So table, so that are the relations. Yeah, so each table contain the data about a specific type of entity. So here, the first table is about the project. The second table is about the entity department. So the relationships are the connections between tables and established associations among entities. So entities are the objects, as I mentioned earlier, objects or concept, while attributes describe the characteristics. So table hold the instance of entities, and relationships define how they interact. So in relational model, so entity representation, each entity correspond to a row in a table. And attribute representation, so entity attributes are mapped to a table columns. And for example, as mentioned here also, and we take another example, that is, say, employee table. So rows representing individual employees, and columns representing the attributes like name, age, position. So those are the examples for a particular relation in the relational database. And what are the key points? Data becomes structured, organized in a tabular way. and the relationships between tables enhance the say the interconnection. It means the coherence of the selected relationships. So uh, so as I mentioned, so the each row that is entities and the columns uh, in a table represent the relationship. So entity attribute relationships allows for precise representation of the information. So here in project table, you can clearly show and it is clearly visible about the projects and what are those projects is about and what are the departments. So those informations can clearly visible uh, in this two-dimensional database. To establish this database, so you can talk in the visual aspect. So illustration of how tables can link through relationships. So means talk about the significance. So relationships enhance the relational models capacity to represent complex data. So as a scenario, so linking employees and departments. So that table will show which employees belong to which departments and so on and so forth. Here, the project table will show which each project is going in each department and what is the department is about. So the relational database model uses tables, organize data with rows representing the entities and columns representing the attributes. So provides an initiative structure to approach the management of the data and flexibility that is enables establishment of relationship between tables and complex data representations, right? So those are it's about the relational database. Um, so in simply, so relational database is about the relation between each entities and the data. So the next thing is how to manipulate those data. So after you enter in the data into a relational database, so then the then each users can be able to access those data and query through those data. They can manipulate and analyze those data. So the purpose is enables users to extract specific information and gain insight from the data. So what are the operations? As mentioned here, the first one is select. So that means filtering rows based on specific criteria. So as mentioned here, eliminating rows according to certain criteria. So you mean that means selecting specific kind of data. Let's say what the previous example that you need to select the department name of the project 155. So that means you are going to eliminate all other information. right? And the next thing is projecting. So it means removing columns to focus on relevant attributes. So if we take this example, so as I mentioned earlier, I need to know about only the uh, department name of the project 150 hours. So I don't need the description of that department and department number also, only the 155 and the department name accounting. So you can you need to eliminate others and only showing the projection of this needed component. So the operation is join. So I already joined two tables to show that the project 150 is on the department of accounting. So joining is combining data from multiple tables. So these operations, selecting, projecting, and joining, will help to refine and analyze data effectively. So these are the foundation of query relational databases. So yeah, you can. So I will give you some insight how to do that. But I think it's not necessary for this subject. So one thing, uh, like there are a few number of queries. So I think I have that slide. Yeah, here. So some of those queries, select client name, uh, and debt from the client where the debt is more than 1,000. So those are some of those queries. So those will going to eliminate some rows and some columns and only select some highlights of the selected uh, or uh, the idea that you need to do all the manipulation, you need to do all the selected data. So these are the examples for relational models. So Oracle uh, is a widely used relational database management system developed by Oracle Corporation. So it is known for its scalability, security features, and support, uh, and commonly used for enterprise level applications and mission critical system. So IBM DB2. So it's a family data management product, including database servers developed by IBM. So it offers strong data security, compatibility, and support various programming languages also, and you can use in large-scale enterprises for manage structured and unstructured data. And some of you have mentioned SQL Server. So service also so relational database management system developed by Microsoft. So it's known for the integration with Microsoft technologies, data warehousing, analytic capabilities. So mostly will use in business intelligence, as I mentioned earlier also, and e-commerce web application. So Microsoft Access, uh, so another DBMS system, uh, its primary target for smaller scale projects. So it offers user-friendly interfaces suitable for creating desktop kind of applications, and so often used in personal projects, small business applications, and departmental level databases, maybe. So MySQL. So it is open source, uh, and it is very speed, reliable, and it's very easy to use. So in that case, it will widely used in web applications, and frequently used in web development and content management systems, e-commerce platforms, and so on and so forth. And the Sybase, so it is a non-SAP system. So it offers high performance capabilities, particularly in financial transactional applications. So then commonly used in industry for fast data processing. So data cleansing. So it is about enhancing data quality. Uh, so data used for decision making, and it is the data is possessed with various attributes, uh, including uh, accuracy, completeness, and reliability, relevance, and security. So high quality data ensures informed and reliable decision making process. So it means for a reliable decision making, so data should be higher quality. What that means? So that means accurate data supports accurate insights. So incomplete or incorrect data uh, can be lead to a wrong decision or fraud decision. So in data cleansing, it means also known as data cleaning or data scrubbing, is process of identify and rectifying incomplete, incorrect or irrelevant records within a database. So even managing duplicates, not managing, actually removing duplicates. So in data cleansing, it aims to enhance overall quality and reliability of the stored data. So as I mentioned, it will help to accurate analysis and informed decision. So this is the process. So first thing is the detection. So that means identifying incomplete, inaccurate, or irrelevant records. Then we need to correct those, and then we need to verification. That means ensure the quality and accuracy of your clean data. So goal, let's come to the goal of data cleansing. So one thing is data quality enhancement. That means improve accuracy and completeness and reliable, and decision making improvement, and operational efficiency. That means reduce errors and inefficiencies caused by poor data. And the next thing is compliances. So that means meet the data uh, governance and regulatory standard. So let's talk about the data cleansing solutions. So one example is cross-checking data against validated dataset. So let's take a scenario where verifying street numbers and street name, city, state and zip code entities against the United, and it can verify it with against the United States Postal zip code database. So validated data sets serves as reliable reference point, and the cross-checking ensures accuracy and completeness. So talk about the benefits. So first thing is enhance and data quality and improve decision making, cost saving, as I previously mentioned, operational efficiency, compliances, and lastly compliances. That means that meet the regulatory standards. So in SQL, so SQL is structured query language. So so it is specialized programming language tailor-made for relational databases. So it empowers efficient data access and manipulations. So the main properties of SQL databases are these ACID properties. So ACID is what? Atomicity, consistency, isolation, and durability. So what are those? So atomicity is atomicity guarantees that a transaction is treated as a single. So transaction means some query for a particular database. So that transaction is treated as single indivisible unit. So you can divide into smaller units. So either entire transaction completed successfully or none of this it is applied. So that means if you do some thing to a database, it's taken as a whole complete thing. You can't divide the actions, that is accessing, changing to a data and storing those. The whole transaction will be treated as a single unit. So if something happened in the middle, then it means the transaction is not occurred. If it's occurred smoothly, then only taken as the action is complete. So that means if either it's completed or none was applied. So in this principle, it prevents partial changes. So so that means the database will be remains in consistent state, right? So then we go to the consistency. So consistency is ensures that the transaction brings database from one valid state to another. So if that atomicity is there, that means you can't divide the single transaction or single operation for a database. Then if that transaction will be occurred or not occurred at all. So if it is not occurred, so the database will be in a previous state already. And if it is occurred, then also it's going to update for another consistent level, right? So that is it also in another valid state. So if a transaction violates any predefined rules or constraint, the database remains unchanged. So it means that this prevent any data inconsistencies. So those will be arise in, as I mentioned, complete transactions. So if the transaction is incomplete, as I mentioned earlier, the uh, database will be held in the previous state. So next property is isolation. So isolation emphasizes that transactions are executed independently of each other. Each other. So when there is multiple transactions uh, executing in concurrent, that means if you are putting the data or data into some exact place, so like two different transactions going to put data into same place. Let's say some another way. So one is going to place data to a some particular place, and other transaction going to access that particular place uh, for another transaction. Let's say one will be going to update the dollar rate, and other transaction will be taken the current dollar rate, and it will do that task. So there is a problem, right? So if the coming transaction where it's going to update the dollar rate, then uh, in the same time, some transaction going to use the same data. So then there should be mechanism to avoid conflicts. So isolation, even when multiple transactions are executed concurrently, they are isolated in a way that the result is the same as if they were executed one after the other. So that means this avoids conflicts and maintains data accuracy. So here, if that occurs in same time, those transactions will be done isolation. So that means it will not going to affect two other transactions, even if it is done one after the other, right? Uh, it what do in the SQL language. The last one, durability. So durability ensures that once transaction is committed, uh, the effects are permanent and won't be lost. So even in the face of system failures. So that means if the transaction is already happened and if there are system failure or something or occurred maybe it, but even that it going to hold. But let's say some thing is the power cut or some system failure happen in the middle of the transaction, then as mentioned in the consistency, there it will be going to not going to override the database. It will going to override at the very end of the transaction. So after the transaction, the effects are permanent. So that means even after the system failure, we can able to back up and restore our data. So that means the changes made by committed transactions are stored in durable manner to provide reliable data state. So these are the ACID properties about the SQL databases. So ACID guarantees the data integrity by prevailing incomplete, invalid, or conflicting changes to the database. And the other thing, reliable transaction. These properties ensures that the transactions are dependable and predictable, promoting users' confidence in the database accuracy. So when it comes to the business continuity, so durability in particular support of business continuity by safeguarding the data even during system failures. So these are about the SQL databases and the ACID properties. Do you have any problems up to now, students? Yeah, I will move forward then. So these are some few SQL queries. So you can go through each. So relational schemas. So definition is database outlines the in relational schema. In a database outlines the structure of tables, fields within those tables, and the relationship between them. So schemas provides a clear framework for data storage and retrieval. So schema is a kind of a blueprint of database, tables, fields, and relationships, and they will show a central to some kind of a design. So it means a schema is some kind of a outline, or that means will show the data as it is, but in a virtual way. So in a large database, maybe like Oracle, they utilize schemas to define table and other database features for specific users of persons. So the function is schemas help manage and organize data associated with individual users. So, in a large database where thousands or let's say millions of data are there, and schema by using the schemas, we can only gather the selected fields and attributes of data, and then we can use that particular schema to do our problems. So that will going to reduce our problem. So in data retrieval, so database management systems reference the schema to locate and request the data and understand its relationship with other pieces. So schemas facilitate efficient data retrieval. Like we are taking only the selected uh, informations. So it will we can efficiently retrieve data and relationship information. So schemas will guide data access within the database, and they ensure accurate data linkage and extraction. So data definition language DTL can be used to create those schemas, and DDL consists structures, instructions, and commands for define those uh, schemas. That means defining those data tables and relationships. So DDL defines database structure using specific syntax. Schemas encapsulate DDL instructions for table creation, alteration, and deletion. So that means there is a database also, but we are taking some only the necessary part as a schema, and by using that schema we can do the certain works as we are going to do with the selected database. Yeah. We do not need to go through with how to the creation. So let's say there are some as mentioned here also. No, not mentioned here, but you can search through. There are few codes like create table, alter table, drop table. So those are the components of those DDL. That means data definition languages, and to allow to create those schemas. So what is database administration? So it is a profession, skilled information system professional responsible for managing and maintaining those databases. So it's called the database administrator. And so role database administrators to ensure the database meet the corresponding business need or the user needs and perform optimally and remain uh, it is secure. So DBAs bridge the gap between technology and business requirements. So that means they are working with the current new technology, and they will the persons who are responsible to manage and maintain the database. So they play a crucial role in data integrity and accessibility. So their responsibilities are the data needs assessment. So that means collaborate with business users to define the data requirements and database design. Craft databases using the programming languages as I mentioned SQL and the other thing performance evaluation. So they should be able to assess and test the database performance. So like if you need to retrieve a particular data and it will take let's say 3 seconds, and there will be millions of transactions going to occur in a single millisecond, then the system not going to hold. Even the 3 second is small, but the use case is need to deal with let's say 100,000 data for a small millisecond. Then it not going to hold. So they should need to evaluate the performance, and it should be relevant to their uh, application. And then the performance optimization. So that means implement changes to enhance database performance. So you need to keep update, and they should need to maintain the security. So how to become a DBA? So what are the skills? So they need to understand the business requirement. So clear comprehension of organization and fundamental operations, and they need to aware of database management systems, and they need to proficiency in selected DBMS technologies, and need to have some quite experience also and technology aware. So they need to update with the emerging technologies and design approach suitable approaches, and proficiency of empower DBS to effectively manage and adapt to change landscape. So those also need to be aware. So you can learn more about their life cycles, like how to plan in design, how to monitor those uh, systems. So you can do some homework and find out how they are doing those activities. So mainly the DBAs are involved throughout the database lifecycle. And so their role is is highly uh, appreciated in database health and performance. So even that they are uh, taking a major role in data-driven decisions as well. So these are some popular database management systems. So you also give some few. So these are the open source MySQL, PostgreSQL, and SQLite. So these are some uh, relational database systems in a enterprise level, and like in like a small enterprise level, and after that Oracle, IBM, too, those are in a large scale enterprise level DBMS softwares. So the next topic is about big data. So currently you are aware of how to deal with data and what are the tasks of database management systems, and who is the DBAs, and what are those as languages and properties of those languages, and what are the operations you are dealing with databases. Those are called operations, and you have some quite understand. And in modern world, so there are systems that are going to deal with like a large number of data. Let's say even in a simple millisecond, like in Amazon, they are dealing with millions of data in a single millisecond, right? So then it's come to the this topic, so-called big data. So big data refers to vast and intricate collection of data. So typically on the scale of more than terabytes, and encompassing various types such as maybe the sensor data, social media data. As I mentioned, the Amazons, they hold the customer transactions, and the complexity and the volume of that data will exceed the capabilities of traditional data management software, even the hardware and the method. So we need to come up with new technologies. So big data is categorized by its enormous volume and the diversity. So as I mentioned, traditional approaches are not going to hold. So those are struggle to handle such massive data sets. So what are the key characteristics of a big data? Especially volume and the variety. That means uh, there can be diverse in the types of data, and even they may be structured and maybe unstructured. And the velocity, that means data produced and consumed at a high speed, like millions of data will be going to do the transactions will be occurred in a millisecond. So and the data quality and trustworthiness is essential, and extracting insight and value from the data, like if data occurs in large number of uh, the time frame of a, let's say, simple second, and we need to deal with them in the same speed. So extracting and even get to some insight also need to do in that scale. So the challenges are storing. That means a massive number of volumes of data are there. So it's very it's the main challenge to store, and then the processing and the analyzing, and we need to have a security measurement to ensure the data protection as well. So so about the applications, so there are a lot of business analytics are based on big data. So data driven so making data driven decisions for improved business outcome can be do using the big data. And when it's come to healthcare, they analyze medical records and personalized treatments, and about the IoT. So we need to deal with massive number of sensor data, uh, and those data should be interconnected with these devices. In the social media, so understanding user behaviors can be done using big data. So technologies uh, that arise with the big data, the distributed compute. So distributed systems for processing large data sets. So that means if you need to handle those data sets, like large number of trillions of data, so you can't do in a single device. So there should be a mechanism to divide and uh, do the small tasks in all the divided systems, and finally comes to a process of how to integrate those results and give the final out. Then that comes the NoSQL as well. So NoSQL is not only SQL. So uh, in NoSQL, uh, it will go in NoSQL databases. We can easily handle those unstructured or the semi-structured data. So in relational databases, we are dealing with very structured data. But when it comes to the big data, we cannot do that in a practical way. Uh, let's say about the sensor data. So, uh, so those data can be unstructured. So we need to come up with new technology. So NoSQL is such one application to deal with unstructured and semi-structured data. Then the machine learning also comes into the picture, where you can extract some patterns and insight of that uh, data, and the data lake. So I will explain more about data lakes. And so simply the data lakes are storing and managing diverse data types. So what are the sources of big data? So organizations accumulate big data from diverse and varied sources to glean insight and driven decision making. So big data originates from an uh, arrays of channels, each contributing to the complexity and depth information. So let's talk about the business applications. So data generated from various business applications, including customer relationship management, CRM, uh, enterprise resources planning, ERP, softwares, and more. So business applications offer insight into operational efficiency and customer interactions. So business application yield operational strategy, data, and insights aid in optimizing processing and enhancing customer experience. So about the social media, so data harvested from social media plus platforms capture user interactions, sentiments, and trends. So social media data provides window to customer behavior and public opinion. So you may probably aware that uh, back in maybe the last election, how the social media deal about the public opinion and the social media analytics inform making, inform marketing strategies and brand perceptions. So data mining reveals insight of hidden social interactions. About the sensors and controllers, the data from sensors and controllers are embedded in manufacturing processes or environmental management systems. So sensor data enhance operational visibility and optimization. So sensor generated data enables real-time monitoring and control. So the precision of those data contributes uh, to efficient resource management. So likewise, media sources. So it also including news, entertainment, and other media content. So about the impact, the media data analysis can be changed or like uh, yeah, can go the audience preferences and predict it. So media sources offer insight in public sentiment and interest. So they are the people who are change those patterns. So in those applications also the big data will comes up. So you can go through with others, machine logs, records, and all data, public source archives such as government websites. So in conclusion, so big data originates from diverse and varied sources. So there are richness of insights. So that means data diversity enhance the analytical depth, and there are a number of applications that give insight to various sources of data-driven decision making. So understanding data origins is vital for extracting meaningful insights. So these are the technologies used to process big data. So example, data warehouses, data masks, and data lakes. So about the data warehouses. So it's a centralized database that aggregates business information from diverse enterprise sources, uh, encompassing processes, products, and customers. So data warehouse facilitate decision making by providing comprehensive insight into organization. So importance of data quality, that means data quality is paramount as data warehouses serves as decision making platforms. So its high quality data ensures accurate and reliable insights. So that will prevent enormous erroneous conclusions. And data warehouses are continually refreshed with data from diverse sources. increasing the likelihood of the dirty data. So, about the dirty data, so that means inaccuracies, incomplete data, and inconsistencies. So, data warehouses are prone to receiving data with quality issues. So, in data warehouses, there are not going to be any erroneous data. So, we need to address dirty data in essential form, maintain the data integrity. So these are the techniques: the ETL, extract, transform, load. Process is central to data warehouses maintenance. So let's go them in detail. So before that, so ETL ensures data consistency, quality, and uniformity, and its transform data aligns with warehouse structure. So, but the ETL, extract, transform, load process, is the fundamental component of data warehouse management. So that means ETL converts raw data from diverse source into structured processed data suitable for a data warehouse. So ETL, the extract, the first one, extract process. So extracting data from multiple sources and converting it into a unified format. So purpose is ensures the consistency and compatibility before transforming and loading. So extraction eliminates sources data disparities. So data fall in expected patterns may be rejected. About the transform. So applying rules and algorithms to extract the data to derive data for storage in data warehouse. So function is to transform data into standardized structured format. So in transformation, enhances data quality and uniformity. So algorithms aid to derive meaningful insight in the transform. So last process is the load process. So loading transform data to the data warehouse. So action is to create new indices, checking data against schema constraint for quality assurance. So ensures the data warehouse's integrity and consistency. So the loading stage includes data verification and the indexing action. So quality check supports reliable data storage. So speak about the data load duration. So loading data into the large data warehouses can take considerable time, and the size and the complexity of the data contribute to the load duration will be the impact, and the loading data for substantial data warehouses may require days. So ETL, the extract, transform, load, directly influence the quality of data within the data warehouses. So, and there are data cleansing also. So ETL can identify and rectify the data quality issues, as mentioned in extracts, transform. And ETL contributes to the data integrity and accuracy. So definition, the ETL tools are software solutions that are streamlined and automate the ETL process in the data warehouse management. So The ETL tools enhance efficiency and accuracy, as I mentioned in a previous slide. And ETL tools are essential for managing the ETL process. So the examples are AB Initio, IBM Infosphere, Oracle Data Integrator. So likewise, and SAP Data Integrator. So there are some open source tools as well, Avatar, Clover ETL, Pento, Talent. So benefits about these are the open source ETL tools offer cost-effective solutions with customized options. So open source tools build organization with budget constraint as well. About the features of these tools. So one of is data extraction. That means pulling data from various sources. As I mentioned, the data transformation, the key part, the applying rules and algorithms to modify data, and final data loading. So loading transform data into the data warehouse. And the next feature is workflow automation. So designing and automating ETL workflow. So there is some considerations you need to aware when selecting such ETL tools. So first one is scalability. That means ability to handle large data sets and growing needs. And complexity. So if the problem is complex, so that means you need to deal with complex data. So your tool should be compatible and suitable to handle those complex data transformations, and the integration compatibility with existing data infrastructure. And you need to aware of the cost as well, relating licensing and support expenses and all. So this is about the ETL tool. So as a recap, ETL tool are pivotal in data warehouse management. So commercial and open source tools are there that need to deal those diverse kind of needs. So ETL tools that automate and streamline data preparation, and ETL tools are essential for efficient data warehouse operations. So I will quickly go through about data mart and data lakes. So as mentioned here, also data marts is a subset of the previously explained data warehouse. And so it will deal on analysis, sales, inventory, or other vital business. So about the purpose of data mart, so it enable online analysis of business data for smaller business and departments. So it is the subpart of the same data mart. So about the characteristic, subset focus, that means data marts contain data specific to a particular business aspect, and departmental scope, that means design for individual department or small business units, and it has efficient in analysis. So some examples are finance data mart, analyze financial data for budgeting and forecasting. Inventory data mart, managing inventory levels and supply chains. Personal data mart, tracking HR related matrices. So comparison with data warehouses. So data warehouses are centralized repository for enterprise wide data, but data marts are subset focusing on specific business aspect. And data marts provide tailored insight for more specialized anchor. So the advantages are efficient analysis, department autonomy, and improved data making because it is tailored inside to a particular department or small kind of business and all. So about the data lakes. So data lake also known as enterprise data hub. So it is a repository that stores vast volume of raw data, raw and unprocessed data. So that means it in the particular data lake, it has all kind of data. So it means store everything. So data lakes preserve data in raw and unaltered state, and data lakes are hubs for exploring new insight. So about the workflow, uh, so it's store raw data, and when we come to the access data is needed for analyze, and then data process. Data is transformed, organized, and data is need to transform, organize, and classified for specific analysis. And those process data will need new insight, and we need to do those all the tasks. That means store and access and process and extract insight. So some examples are business transactions. So financial and operational data are some examples, and click stream data. That means user interaction on websites and apps. So you may aware you do a lot of Google search, and those all the information going to store in the data lakes of Google. So all data are there. So when it's come to the IoT, the sensors data also is stored in the particular data lakes, and server logs. But social media, the user generated content. When you are going to Facebook, you do various things, and those are going to store in those data lakes. That's why when you are uh, like speaking to a phone or something, and probably those things will be going to appear in your Facebook content, right? So that means everything is going to store in these data lakes. So there are some advantages, that are flexibility, like we can easily store those data, and the raw data is available for the custom analysis also, and is cost efficient. That means storage without upfront data processing. You do not need to do any pre-processing. And the other advantage is future proofing. That means data readiness for evolving analytics needs. So if you store those data in exact as it is, then in future you can find out some hidden insight also. So that are some advantages. So when you are dealing with data lakes. So this is the part that I have this time. Okay, so this is the part that I have included to your syllabus. vector databases. So nowadays, in very recent, in end of 2022, after the those AI algorithms, ChatGPTs and all, come to the industry. Now there are some databases called vector DBs that have uh, the vectors that are already trained from some kind of a selected AI algorithm. So that means if you are dealing with, let's say, natural languages, and those data are stored in a vector way. When you are going to create some AI application, you will need to uh, map those words and all those natural language data to some kind of a vector. And those vectors will save exact as it is. Then uh, when you need to query to those databases, what you can do is you can create a query also by you can give the query also by as a transform that query into a similar vector. Then it will do some vector multiplication and vector uh, calculus, and after that it will generate some another vector that will have the answer, and after that we can convert into a natural language. So this is some utilized way of optimize storage and retrieval. So purpose is designed to handle intricate data types like numerical vectors, arrays, and tensors uh, to store in those databases. So vector database excel in managing complex data tailored to diverse application in information systems. So about the benefits, some accelerate complex queries for real-time analysis. So empower faster decision making and streamline data retrieval, flexibility. So adapt to in evolving data demands without compromising performance. Accurate, diverse data types for comprehensive insight. So I think you can learn more about these when you are doing those AI activities and all. However, the insight is to give us some idea that when you are dealing with those applications, you are not going to deal with the same databases that we have previously worked for. You will going to work with only the numbers, and those numbers are saved as it is and as a vector. And what we can do is we can generate our queries as a vector also to deal with that databases. So those will happen in these vector DBs. So we can end up the sessions from here. Do you have any questions? Like you will not, maybe you not going to didn't learn anything or you have learned everything. But however, please go through these concept, and yeah, probably I will give you some talks also after finishing a few lectures to do some self studies also. And in this course, we especially I will not going to ask about the worries. Just need to have some kind of idea like about the concept acid properties and CRUD operations, and some examples of those DBs and relational databases, how the entity relationship is created. So likewise, some basic idea you need to have from early days, from starting with those relational database to NoSQL database to finally to vector DBs. Right. If you have any questions, you can ask now, and if you don't have any questions, we can wind up the session. Students.